2017 Chevy Sonic push start. Problem is they were welding on here somewhere. They said they disconnected the positive lead, and after they finished welding, they put the battery back and try to start it, and no crank. So you just hit the ignition switch and gauges come on and everything, but nothing. I just tried to scan it, and I had no communication with any modules on the CAN bus network. I can communicate with some modules on the low-speed bus or the GM LAN. I'm going to show you. No crank, no start. Okay, guys. Here are the modules that I can communicate, and you can see the ECM is offline. Here's the aftermarket color wiring diagram, and here's the actual OEM BCM wiring diagram, so you can see how the connection is. And we're going to target the BCM first. You can see there are two resistors. You could pause and bring that back. Here's the full network. Here are the connections on the BCM that we're going to target, and some of the pin outs. So just look over this, pause as you need, and we're going to go straight to the BCM. Okay, guys, so we got the we're using the Gotcha Fix 3-in-1 multimeter oscilloscope. If you haven't seen my review on this, definitely check it out. They sent it out to us, but honest review, and I'm actually using it. It's on the field. I'm using it all the time now. But here is the BCM. So if you saw, I'm going to show you the network diagrams if you haven't seen it already. But basically the DLC, the colors I have on the color diagram is a little different. That is CAN high, it's like a greenish color, and then that yellow is going to be a CAN low, and that's what that is coming in. It comes into the blue connector here. Let's see if I can get you to see that. So you see there, and there it comes in. Then it actually reaches 260 ohm resistors in the X6 connection. So right now, because when everything is plugged in, I'm getting 3 ohms. I want that in money. Okay, so as you can see, I'm getting about 122 ohms, and that is seeing the 260 ohm resistors inside that BCM. So that tells me that leg of the network is good. So I'm going to check now the leg coming out of this network, and I should be seeing about the same 120 ohms. So let's try that. Okay, so this white connector is, I believe, X1, and it goes out to the network. So that will be this yellow and this like what is that, like a greenish color right here. That's the network coming out, going out to like the engine computer and all of that. So I should also have 120 ohms here. Let's try that out. All right, it's actually these two pins right here go out to the network on the white connector, and here is what I'm getting, 3.4 ohms. So there's going to be a physical problem there. Either wiring is damaged somewhere, or a module is actually causing this. So we're going to have to go down the network and find this physical problem. Guys, I might have found a problem. I'm tapped into those same 2 wires here, and hold on, let me care. And we disconnected the transmission. I went down the line, took off the engine computer, and we still had the short. I took off the ABS module, still had the short. So the next line was in the diagram that you saw was the transmission. Enchufa ahí la transmisión. So now I had him go ahead and plug in the transmission, and we should see a difference when the transmission is plugged in. That's going to tell us that the problem is going to most likely be at or after the transmission, and we're going to find out if it's after the transmission in a second. I'm going to show you. See, now he plugged in and I got 3.5 ohms. Quítalo. So that's what's happening with the transmission plugged in. We're getting 3.5 ohms. So the problem can be literally at that TCM. I'm moving a little bit here, that's why. But that's what's going on here, guys. So let's find out what's going on. Right, this is the transmission connector. We just pulled it off from the transmission right there. And what we're doing is actually bridging the CAN bus network here at the transmission, because it does a loop itself. It goes into the transmission and comes back out. This is GM's design on their networks, which I think is stupid. It causes stuff like this. So we're going to bridge it. So we're going to bridge the 2 whites at the bottom, which is 8 and 14, and then 6 and 7, which is the 2 blue cables. I'm going to show you better in a second once he's got them in. So he's got these 2 right here. The first 2 on this side are the blue. You can see that down there. You can see the blue. Those 2 are bridged, and then the white, which is 8 and 14, these 2 are bridged. So that's what it is. Okay, so we're back here and we've got the transmission connector bridged, and we're getting, as you can see, 110 ohms. We should really be seeing 120, but this could account for some other connections and things like that. But the main thing is the bridge, or the short that we saw with the TCM plugged in, is gone. So that tells us that that short that we had to 3 ohms, I believe it was, is internal into the transmission, since we bypassed the transmission right now. In fact, if we plug everything back up, if this vehicle is able to start without the transmission, it might actually start, but I probably will have communication back with everything. So in fact, let's go ahead and do that. We're going to plug the BCM. Mano, vamos a poner el BCM para atrás. Just to expand, if you look at the network diagram, pretty much right here at the front engine bay, the transmission connector is the first one in the line that will cut the bridge to the rest of the network, right? So then it will continue, I believe, to the, can't remember. You've seen the diagram, either the ABS, power steering, and then the engine computer. So by me disconnecting the computer and the ABS because they were easy to get to, and I still had the bridge, the next easiest thing for me to disconnect was the transmission here. That's why I disconnected the transmission. And of course, the short that I saw went away by disconnecting the transmission, which does not mean that it's not after the transmission, right? Because there are other devices and a bridge or a bus bar, bus connection after the transmission. The problem could have been there. So I bridged the transmission connector to basically bypass the transmission completely and continue the network. And I'm seeing this resistor here at this engine computer, which is showing up at about 110 ohms right now, which tells me the problem is internal to the transmission. Some damage, electrical damage, got done to the transmission, which fried that TCM. So that transmission TCM is going to need to be replaced. By the way, this test is done with the battery disconnected. That just makes it easier so you don't have anything possibly powered up to give you some kind of interference on the CAN bus. So the testing you're doing is a physical connection test, right? So it doesn't have anything to do with computers, anything like that. It just has to do if the wire is reaching and seeing the resistor at the end of each wire. All right, guys, so now we got everything hooked back up. The whole network is connected except for the TCM, which we still have bridged. And now we're in the DLC between 6 and 14 with our meter. And we've got, I was a little bit off on my connection there. And we got close to 60 ohms, guys. So we're seeing both of the resistors. So with everything connected up on the network right now, as you can see, and we're just having our jumper leads to bypass the transmission, we have full connectivity all the way back to the PCM. So that confirms it 100%. So I'm going to see if I can communicate now. Now, as you saw that, I got connectivity with the computer now, so I'm going to try to start it. Got the key here. So let's see what happens. It might not start because the transmission is offline, but I do have communication with everything. So it's pretty much showing you like the same symptoms, but of course I know I don't have any communication with the transmission. Let me just do a full scan and see what we got. Okay, we plugged in the transmission back, and let's see the difference in the network. All right, we got the transmission plugged back in, and as you can see, we're shorted down to 3.4 ohms, guys. So that is a confirm that we are looking at an issue in the transmission. So that's it on this one, guys. There might be a part 2. He's going to get the transmission module, and we're going to reprogram that for this vehicle and start it. So stay tuned for that. But it's like I always say, if you didn't know this, now you know. And knowing is half the battle, boys. See you on the next one. Click that thumbs up button.